Context Engine is the newest feature for Maya, which builds a living map of your business logic from your data warehouse structures and relationships. This map enables Maia AI agents to naturally speak the language of the business and build highly accurate data pipelines. In this tutorial, we will explore two live scenarios that make use of Context Engine. The first is a top-down analytics query in which Maia maps out a subset of physical tables to generate inventory recommendations. The second is a bottom-up data discovery session showing how a new team member can immediately locate and map critical customer data references using Context Engine. So let's take a look at these examples. In the first scenario, our buying team wants to know which products are performing well to make holiday restocking decisions. In this case, it's important to know that the context engine was already set and populated beforehand. They've asked Maia for product trends and inventory recommendations. Watch how Maia automatically begins by searching our semantic layer. Architecturally, this leverages an agent-sub-agent pattern. The main agent delegates the semantic search to a specialized sub-agent, populating its context with specialized graph data, and returns only the final relevant nodes, which protects the main agent's context from being flooded with raw database schema data. It also narrows down the problem space for Maia so that it acts quicker and on the right subset of data assets. The prompt query for the sub-agent is shown here. Its purpose is to identify logical product entities by examining inventory metrics, orders, pricing, categorization, and identification to maintain connectivity within the appropriate domain. The sub-agent returns tables containing sales metrics, product details, and inventory levels. To locate these assets, it starts with a vector search across the knowledge graph, matching semantic descriptions of entities and tables against the natural language prompt to find an immediate starting point. Because the graph is dense and highly interconnected, the vector search provides an optimized entry point. Once this initial target is hit, the sub-agent executes a pivot search to explore nearby entities and map out relevant clusters. To traverse the graph database, the sub-agent dynamically writes and runs open cipher queries, which is essentially an SQL-like language explicitly optimized for graph structures. After exploring the graph, the sub-agent returns a structured summary to the main agent. It confirms that it has identified the core e-commerce structures and maps out specific logical attributes such as product IDs, SKU codes, and category details. It isolates the logical attributes and identifies the concrete database tables backing them. This bridges the abstract business query with actual physical infrastructure, mapping entities such as sales transactions, orders, and inventory levels. Next, the sub-agent outlines how these logical entities relate to each other structurally. What makes the context engine so powerful here is its ability to bridge two different worlds. It seamlessly traverses explicit physical relationships, like foreign key constraints, while simultaneously mapping out the implicit big picture relationships inferred within the business graph. This unified structural summary is handed back to the main agent. The main agent reports the discovery of a comprehensive e-commerce dataset and prepares to explore column-level metadata in these isolated tables. At this stage, standard Maia functionality takes over. Having successfully scoped the entire warehouse down to the target tables, Maia investigates column metadata and samples data to finalize its pipeline blueprint. This highlights the core purpose of semantic search. It serves as an automated context scoping mechanism. Out of 46 complex database tables, Context Engine instantly narrowed the active workspace to 6 target tables. With the correct tables identified, Maya builds the analytics pipeline, samples live metrics, and compiles the final holiday trend report for the buying team. That covers our top-down business query. Now let's look at the second use case, a bottom-up data discovery session. This is incredibly valuable for onboarding new team members or running fast analytics mapping. Imagine a new employee who needs to work with customer records but doesn't know where the customer records live. Historically, they would spend hours searching through stale documentation. With Context Engine, they can simply ask Maya to find every table holding customer information. This showcases bi-directional search. The user queries a high-level concept, and Maya crawls upwards and outwards from physical assets to find all related logical entities, mappings, and dependencies. Maya immediately issues a targeted query to find all logical entities tied to customer information and reference data. From there, it follows the same semantic graph traversal pattern. Vector search finds the best starting points, open cipher queries explore the graph, and the sub-agent turns the results into a structured workspace summary. The search identifies the sales and customer management domains and pinpoints 4 core entities, along with the master tables that contain all the customer information. It isolates standard customer fields like email addresses and phone numbers, and maps them directly to the underlying master dimension tables. It also traces physical locations and addresses back to the corresponding dimension tables, mapping out identical structural connections across the database landscape. Finally, Maya maps out the key dependencies, including how customer records connect to orders and sales transactions. It then brings this information together and points the user to the right master tables, such as dim_customer and addresses, along with the related fact tables like fact_sales. So we've seen how Context Engine helps Maya move from a high-level business question to the right data structures behind it. By using semantic search and graph traversal, Maya can connect business terms to warehouse tables and return a clear view of the data needed for each task. If you want to learn more about Maya, go to maia.ai.